Hi, welcome back. In this video, like in the previous video, we talked about meshing, like meshing in general for the chunks. And today we're going to take a look at the LOD system. And so as you can see in the back, we have chunks that are less defined than the chunks that are very close to the player. By the way, the player is this red sphere. And so the chunks that are very close to the player, the chunks that are very close to the player have like, you know, the one-to-one scale, so the blocks can be interacted with, like it's the actual world, right, as the player will experience it. And in the background, we have, hopefully you can see that we have chunks with much bigger blocks. So they have less blocks overall, and the blocks are bigger. And you can see here the transition, like each block is actually, like in this case, each block is actually 2 blocks. Oh, no, sorry. Yes, this block is actually 2 blocks. And as we go far away, it's getting even bigger. So we have multiple level of details. And so just a very quick summary about what level of details is, because maybe some of you may be complete beginner with that, which is completely fine. And so when we want to have big worlds with many different meshes at the same time, we want to try to find tricks to reduce the overall amount of geometry to draw on the screen at any given time. And so one of these techniques is to generate a lower res representation of the same thing. And so if you take a look at these chunks right now that are in the middle of the screen, as I move my player away, you're going to see that, yeah, they get less defined, basically. And so usually Unreal Engine and most game engines, what they do is that so each asset has a pre-baked set of LODs. Unreal can have 8 LODs maximum, I think. And so when you play, the engine will just swap for a lower res LODs based on the size on screen. It's not based on the distance from the camera. It's based on the size on screen, which is important. And it's important also to mention that because in my case, I'm not using the built-in LOD system in Unreal. I'm using my own custom thing, which is very stupid, but it's better in my case. So I'm using the distance from the player to define which LOD to use. I am not baking all LODs for each chunk. Like each chunk can only know about its current LOD. It doesn't bake all the different LODs variations at any given time. So this is based on the distance from the player. As you can see, it's not based on the size on screen at all. And so why? So not only it allows me to not have to update the meshes as often, because if you're relying on the size on screen, as you move the camera around, it can very quickly, trigger a lot of LODs updates. In my case, it's only triggering an update when the player change the chunks location is in there in. So yeah, it's cheaper in that sense, but also it's because I'm using another set of level of detail. So it's not, so the LOD is purely about the mesh, right? It's purely about the visual representation of the chunk. And I am also maintaining another set of level of detail, which I'm calling LOG for level of generation. And so this is a different layer, basically. And so because it's actually for the same reason. Like the end goal is that we want to display a massive amount of chunks, and we want a huge world around the player. And so to do that, we want to speed things up, because the generation of the chunk is actually the slowest part in the process. It's much slower than the meshing, and so it's even more important to have a level of generation. So as you can imagine, like generating this amount of blocks, you can see the size of the blocks and the amount of blocks that we can see. This is much slower than generating this amount of blocks, obviously. And so again, we have LODs for the mesh, but we have LOGs for the generation. And so this LOG for generation, it allows us to have a lot more generation going on, because it's actually super cheap to generate these kind of chunks. These ones are slow, so I could not afford to generate all the chunks of the map at this level. I mean, right now this map is very small, right? So, but I could not afford a very big map with this amount of detail in the generation. So yeah, we maintain two things, LOGs, LODs, and I'm going to talk about both of them during this video. Okay, so now hopefully you understand more about LOGs and LODs and what they are doing. But now I'm going to show you something that may be surprising, but it's actually not. So let's take a look at this chunk here. So we are at the edge of the map. We are very far away from the player. So this is using the lowest LOD. So sorry, the lowest LOG and the lowest LOD. So this is basically a LOG4 chunk. So as a reminder, the higher the value of the LOD or LOG, the lower the detail. And so I'm going to do something now and then tell you about it. So I'm going to move the player. So again, take a look at this chunk here. And as I move my player closer to this chunk, now if this is this chunk right here, now you can see the amount of detail that it has. So it's been generated to the highest amount of detail. And now I'm going to do something is I'm going to backtrack to where I was, if I can reach. And so now this is back to where we were, and I'm going to tell you that this mesh that we are seeing right now is not the same mesh that we were seeing before. And I'm going to explain why. But for that I need to show you a debug mode that I didn't show yet. So now I'm just, so this is the same map, but by the way, we can recognize this is the same chunk here. And so I'm going to use this, no, not this. Sorry, I'm trying to find my, yeah. So these boxes represent the chunks, and the color of the boxes represent the LOD. So right now we are seeing LOD values. The blue one is LOD 0, so the highest level of detail for the mesh, and the red one is the lowest amount of detail. And you know, as I move around, you can see that, sorry for the flickering, as I move around, you can see that the color evolves around the player. So as a play, oops, I was in the wrong axis. So as the player gets closer to a chunk, it gets toward greens and then blue, and as it gets farther away from a chunk, it gets red, and which is fine. But now I'm going to show you something else. So now, yeah, so now this is again same thing, LOD, and now I'm going to change the color. And be careful, just take a look at the screen, and now I'm going to change the color. Boom. Didn't see any difference, right? So what we're seeing right now is actually the LOG value. So right now the color are exactly the same as the LOD. I'm going to switch back and forth between LOD and LOG color. And yeah, as you can see, the color doesn't change. It's exactly the same. The reason is that I just, like as you can see, I just started the plugin editor. So I just spawned, and when you spawn, the LOD and LOG value of each chunk is the same because they just spawned. So this LOG value is the same as the LOD value, 0 maximum, because it's close to the player, and this one is the lowest for both LOD and LOG. And so now, again, right now I am previewing the LOG, so the level of generation. Now, if I move around, you're going to notice that the color stay the same. Like this chunk is now, obviously, the mesh of the chunk is now much lower res than it was before, but the color of the box is still blue. So the color of the box is the level of generation. So even though the player is farther away now, we don't just toss the maximum LOG data that we have. Like we just hold on the data. We don't want to have to regenerate the highest level of generation. So the level of generation, once it has computed the maximum, like it never gets lower. Like once you have generated a high level of generation, you never go back to a lower level. And again, now I'm going to just change the color to LOD, and now you can see, like, obviously, like, the LOD is purely dynamic. It's always updated based on the position of the player. But now back to LOG. The LOG, like, you only want to ever generate the LOG 0 once. So as I move around and as I generate stuff in blue, so yeah, this is mostly all blue because the player moved around this area, and so all the chunks in this area have been generated to the highest level. And again, I'm going to disable that. Visually, it doesn't change. Like, visually, you still have LODs, and these chunks are LOG 0, but they are still generated with the mesh still have lower detail. And it's important to understand. And I'm going to again go back to the example I was showing you when I was telling you that this chunk mesh was not the same. So if we take a look here, this mesh has been generated from an LOG. So so right now we are seeing the LOD. So the red value is the LOD, and now the color is the LOG. So red value for LOG, red value for LOD. Now if I do this, it's the exact same thing I did before. I go back here and I go back before. And so now these chunks might look very similar to what we had before, but actually it's a different, it's been generated in a different way. That's what I'm trying to tell you. So LOG 0, as you can see from the blue box, and LOD red, right? So, I mean, if I did a screen, like maybe a screen grab of both mesh, maybe we would find some differences in the way the blocks were downsampled. Maybe I will do that if I find, but maybe they will be actually identical. But even if they are identical, the point I'm trying to make is that the meshing algorithm ran through a different process for both meshes. So this mesh is not the same as the mesh when I started the map. And the reason, again, I'm sorry if I'm being too insistent and explaining the same thing over and over again, but yeah, the reason is that now the LOG of this chunk is different. So before, when I first spawned in the map, the LOG was a very low-res LOG, so the mesh was just meshing that data. But now the chunk has actually contained the full data, like these chunks, for example. But the meshing process, because the LOD is red, because the LOD needs to be lower, it's doing some downsampling internally to then just give us the amount of mesh, to mesh the amount of blocks that we want. And so, yeah, and last time in the last video, I was showing, screenshot and animation and stuff, but it was way too time consuming. So I'm just going to show you live now. So this is like presumably the same chunk that we want to represent in various LODs/LOGs. So this is like the highest level, and we have like 64 by 64 by 64 blocks in this case, and this is the next LOD. So as you can see, we have a much bigger box, twice as big actually, and so on for the next LOD, and so on for the last LOD. So I mean, this is pretty obvious, right? This is the whole point of this. Like it's just less and less chunks, but less and less blocks. But maybe by seeing it like this, it's clearer. It's even clearer. And so let's focus on just the highest level of detail for now. And so this is the data that we are dealing with. This is the full resolution chunk. And if we take a look at the other ones again, so let's take this one as an example. So we have this data to deal with. This is the generated chunk with all the blocks that we have, 64 by 64 by 64, and we want to mesh it to look like that. And so as I was saying, this block in here, is basically, let me show you, it's basically 2 blocks wide in all axes. So we want to downsample our data and mesh it like this. And so one easy way to go around this is to just select the first block of each group of 2 by 2 by 2 blocks, and just use the status of this block, like either if it's empty or solid, to just consider this undersampled block as solid or empty. Or you could do the average, like this is more costly. You could take all 8 blocks in this area, in this sample, do the average, like is the majority of the block solid? Yes, so the downsampled block will be solid, else it's going to be empty. But it's more costly. It depends on it depends on the fidelity that you are expecting for your LODs. In my case, I really don't care too much. I don't care if it's accurate or not. I want a fast downsampling algorithm, basically. So I did opt for a quick solution. And if you watch the previous video, you know that we are arranging our data in pillars. So I just selected one. And so this data highlighted in orange is actually represented in my code by a single 64 bits integer. And so to achieve the sample of this size, we would basically need 4 of those pillars. So right now we can see 4 pillars. And so now it's actually quite easy to downsample that, because as I was saying, we are dealing with 64 bits integer. And so we can just cut our process in the sample size. So for example, again, this one here is basically a sample of 2, so it's twice as big as the original block. So what we're doing here is that for all of those 4 pillars, we just go from 0 to the top, and we advance 2 by 2. So we take a look at these 2 guys at the bottom. And in my case, as I was saying, I don't care to do the average or something like that. I only want to consider this block solid if both bits in the 64-bit integer are solid. So I just do a check to see, like, is this sample of 2 bits 2 bits? Yes, it's solid. No, I switch the bit to 0. This is super easy, and you just go sample by sample, and then yeah, you're fine. All right, sorry if that was confusing. I feel like I've explained this very badly, but hopefully you can understand, and hopefully we can just get rid of these fucking boxes. All right, yeah, but it's important to understand because you do need to apply some specific fixes in this case. And again, yeah, I was saying that the meshes were not the same. It's not. I mean, at the end of the day, you might think, yeah, we don't care. And yes, we do not care for the end result. But the point I was making is that you need to be aware of that, and you may need to apply some slightly different method of meshing when achieving that. And so remember the chunk I was just showing you about when I was explaining about difference between LOGs and LODs. Now if I just relaunched the engine, disabling the fix I was mentioning about, when you have LOGs versus LODs, and when you have when the mesh is not the same, you have to apply some fixes. And so now I have disabled this specific fix, and when I go back in here, as you can see, there are holes in the chunks. It's not good. So yeah, you do need to fix that. So this one is again LOD red, LOG red. So there is no downsampling happening right now. It's just purely like the LOD is not doing, like the meshing process is not doing any downsampling. And so when I go back, so now the LOG is 0, and now if I go back, now as you can see that the the same chunk has fixed this issue. So that proves the point I was making, is that, you know, the meshes are not the same actually, even if from the outside they might look almost the same. And so, I mean, maybe I will explain exactly what I did for this fix, but it depends on your project, so it might not be relevant. And one final thing I wanted to mention about all of that is ambient occlusion. At the end of the last video, we were talking about baking ambient occlusion. And yeah, I just wanted to mention that I'm only baking ambient occlusion for the highest level of detail. I am not using baking ambient occlusion in the lower LODs. So as you can see here, clearly on the right you have a LOD 0, so highest detail mesh, and on the left you have lower res meshes, so they don't bake ambient occlusion. You might want to, you might want to do it like that, or you might want to bake ambient occlusion. But as you can see, like when it gets far away, you don't really care about ambient occlusion. And the whole point of LODs is to have faster meshing. So yeah, not baking ambient occlusion is slightly faster, so I decided to disable it for LODs like that. Yeah, and as you can see right now, yeah, we're still in the non-fixed version. I was just mentioning about having to fix the seams, and yeah, you can see all the gaps right now. The dark part between the chunks. All right, yeah, I think that's it. Hi, and so this is just the same thing, but I have enabled a very dumb 3D noise, because up until now, up until now I was just showing you like basically a flat 2D map with no 3D noise going on. I mean, it's an ugly noise, like it's terrible, but just to show you that the LODs, the LOD system also like works. You can't see obvious gaps. I mean, the black part that we see right now are just the edges of the map. But yeah, we can't see gaps or anything between like the LOD transition. And actually, right now the map is quite small, honestly. Because the smaller the map, the harsher the LOD transition. So I will just increase temporarily the size, like the range of the player. Yeah, I mean, as you can see, the 3D noise is really stupid. Like it's generating a stupid amount of noise inside the map. Anyway, but yeah, as you can see, like right now, this looks a little bit closer to what I want in terms of size of the map. Not quite. We can still have bigger maps. I'm just advancing right now. Yeah. So yeah, as you can see, we still have LODs even in 3D, which is quite nice. So these are lower res meshes. Yeah, as you can see, like, this is getting bigger. But yeah, it works quite well. Like it's hard to tell the transition between LODs. Like it's fine. I'm happy with that. Like I was honestly expecting to have more trouble fixing those seams and those gaps, but it's actually okay, even with 3D noise. Yeah, cool.